Humans have always been fascinated by the sky. We look up at the clouds and dream of what it would be like to touch them, to fly among them, to live above the world. This fascination has led to countless stories, myths, and legends about floating cities and sky-bound civilizations. One of the earliest examples is the Greek myth of Laputa, a floating island held aloft by a giant magnet. In Hindu mythology, there's the city of Lanka, ruled by the demon king Ravana, which is described as a flying palace. These stories, though fantastical, reflect our enduring desire to conquer the skies. In more recent times, science fiction has kept the dream of sky cities alive. Books like The Windhover Tapes by Warren Carlberg and films like Star Wars with its Cloud City show us breathtaking visions of cities floating amongst the clouds. These visions, while still fictional, spark our imaginations and make us wonder, could we one day build our own floating metropolises? The idea might seem impossible at first, but the desire to reach for the stars, or in this case the clouds, is a powerful motivator. As technology advances, the dream of living in a sky city might not be as far-fetched as it seems. Before we start designing our dream sky cities, we need to address the elephant, or rather the gravitational force in the room. Gravity, the force that keeps our feet firmly planted on the ground, is a powerful force to overcome. To get anything off the ground, let alone an entire city, we need a force stronger than gravity. This is where the principles of buoyancy and lift come into play. Buoyancy is the force that makes objects float in water. It's the reason why a giant cruise ship can stay afloat while a small pebble sinks. The same principle can be applied to the air, albeit with some key differences. Air is much less dense than water, meaning we need much larger structures and lighter materials to achieve buoyancy in the air. Lift, on the other hand, is a force generated by moving an object through a fluid, in this case, the air. An airplane's wings, for example, are designed to generate lift by manipulating the airflow around them. This force counteracts gravity and allows the plane to stay airborne. To build a sky city, we need to explore technologies that can generate enough lift or buoyancy to counteract its immense weight. This might seem like a daunting task, but with human ingenuity and the right technology, it might not be as impossible as it sounds. One way to tackle the challenge of gravity is to use lighter-than-air technology. Think of a hot air balloon. It rises because the hot air inside the balloon is less dense than the cooler air outside. This difference in density creates buoyancy, the upward force that lifts the balloon. We can apply this same principle on a much larger scale, using massive balloons or blimps filled with gases lighter than air. Helium, for example, is a gas much lighter than air, commonly used in party balloons. If we were to construct a colossal balloon made of a strong, lightweight material and fill it with helium, it could potentially lift substantial weight. Another futuristic idea involves creating a vacuum chamber, a space entirely devoid of any air. Since a vacuum has zero density, it's inherently lighter than air. Constructing a large, rigid vacuum chamber could provide significant lifting power. However, building a structure strong enough to withstand the immense pressure difference between the vacuum inside and the atmosphere outside is a massive engineering challenge. These lighter-than-air technologies offer promising possibilities for creating buoyant platforms that could form the foundation of our sky cities. But challenges remain in terms of constructing these enormous structures and ensuring their stability in the face of winds and weather. While lighter-than-air technologies provide a passive way to counter gravity, active lift systems offer a more dynamic approach. These systems require a continuous energy source to generate the force needed to keep our sky cities aloft. One such system involves using massive, strategically placed propellers. These propellers, similar to those found on helicopters but on a much larger scale, would need to generate a constant downward thrust to counteract the city's weight. This method, however, would require a significant and continuous energy supply, posing a considerable technological challenge. Another intriguing possibility lies in magnetic levitation, or maglev technology. This technology uses the repelling force between two magnets to levitate objects. We see this technology already in use in high-speed maglev trains. By incorporating powerful magnets into the base of our sky city and creating a corresponding magnetic track on the ground, we could potentially levitate the entire structure. While technologically fascinating, active lift systems come with their own set of challenges. The energy demands of such systems are substantial, and ensuring their reliability and safety is paramount. Furthermore, the potential noise pollution generated by massive propellers could pose significant problems. Section 5. The best of both worlds, combining technologies for optimal flotation. To overcome the limitations of using a single technology, a hybrid approach might be the answer. By combining the advantages of both lighter-than-air and active lift systems, we can potentially create a more efficient and stable platform for our sky cities. Imagine a sky city with a core structure supported by massive helium-filled balloons for initial lift and stability. This core could then be supplemented with strategically placed propellers or maglev systems for maneuvering and altitude control. This combination allows us to leverage the benefits of both passive and active lift technologies, creating a system that is both energy efficient and highly adaptable. This hybrid approach allows for greater flexibility in design and functionality. For instance, we could incorporate retractable sails to harness wind energy, further reducing our reliance on external power sources. The key lies in finding the optimal balance between different technologies to create a system that is both practical and sustainable. Section 6. A ray of hope. Powering our cities in the sky. One of the most critical challenges of building a sky city is ensuring a sustainable and reliable energy supply. After all, our floating metropolis will need power for everything from lighting and climate control to transportation and communication systems. Fortunately, being situated above the ground offers us a unique advantage: unobstructed access to renewable energy sources. Solar power, for example, becomes even more efficient at higher altitudes where the air is thinner and sunlight is more intense. We can imagine vast arrays of solar panels lining the upper surfaces of our sky city, soaking up the sun's energy and converting it into electricity. Wind power is another abundant source of renewable energy at higher altitudes. Strong, consistent winds could be harnessed using wind turbines positioned on the city's periphery, generating additional power for our floating metropolis. By combining solar and wind power, we can create a robust and sustainable energy grid for our sky city. Furthermore, we can explore other innovative energy solutions, such as harnessing the energy from lightning strikes or utilizing the temperature difference between the warm upper atmosphere and the cooler air below to generate power. By embracing a diverse mix of renewable energy sources, we can ensure a self-sufficient and eco-friendly power supply for our sky cities. Section 7. Life among the clouds. Building a self-sustaining sky city. Building a sky city isn't just about overcoming technical challenges. It's also about creating a livable and sustainable environment for its inhabitants. This means replicating all the essential elements of life that we take for granted on the ground, from breathable air and clean water to food production and waste management. Creating a closed-loop life support system is crucial. This involves recycling air and water, minimizing waste, and growing food within the city itself. Imagine vertical farms bathed in sunlight, producing fresh fruits, vegetables, and even protein sources like insects. Advanced hydroponic and aeroponic systems could be used to grow crops without soil, maximizing efficiency and minimizing water usage. Waste management would be another critical aspect. Advanced waste treatment and recycling facilities would be essential for breaking down waste materials and turning them into usable resources, minimizing the city's environmental footprint. Creating a sense of community and well-being for residents would be equally important. Parks, recreational areas, and green spaces would be essential for fostering a connection with nature and promoting mental well-being. Imagine taking a stroll through a rooftop park, breathing fresh air, and enjoying a breathtaking view of the world below. Section 8. From Dream to Reality, the future of floating cities. While the concept of sky cities might seem like something out of science fiction, technological advancements are bringing this dream closer to reality. Researchers and engineers around the world are already exploring many of the concepts discussed, from lightweight materials and renewable energy solutions to closed-loop life support systems. We are seeing progress in areas like material science with the development of super-strong, lightweight materials like graphene, which could be instrumental in constructing the massive structures needed for sky cities. Advancements in three-dimensional printing technology could also revolutionize construction, allowing us to print entire buildings or even sections of the city in the sky. While significant challenges remain, the dream of building sky cities is no longer limited to the realm of fantasy. With continued research, innovation, and collaboration, we might one day see these floating metropolises grace our skies, offering a new perspective on life above the Earth. Section 9. Conclusion. A new perspective on life above the Earth. The dream of living in the sky, once confined to myths and science fiction, is slowly but surely moving into the realm of possibility. While we might not have flying cars or cities floating among the clouds just yet, the technological building blocks are slowly falling into place. The challenges are undoubtedly immense: defying gravity, sourcing sustainable energy, building self-sufficient ecosystems. Each of these aspects requires breakthroughs in engineering, physics, and biology. Yet, the human spirit of exploration and innovation persists. Perhaps one day, we will look up not at empty skies, but at thriving sky cities, testament to human ingenuity and our enduring fascination with the world above. These cities could offer solutions to overpopulation, resource scarcity, and environmental concerns, pioneering a new era of sustainable living. The journey from dream to reality is long and fraught with challenges. But the pursuit of building sky cities is not just about conquering the skies. It's about pushing the boundaries of what's possible, about imagining a future where humanity reaches for the stars while still caring for our home planet. And that's a future worth striving for.